Hello friends, myself Darshana Patel, working as an assistant professor at V.S. Patel College of Arts and Science BCA BBA course. I am over here to teach object-oriented programming using C++. In today's session, I am going to briefly discuss about the basics of C++ language, and thereafter I will be discussing what is inline functions in detail. So let's start with the topic. Introduction of C++. C++ is a programming language developed by Barney Stroustrup in 1979 at Bell Labs. C++ is a general purpose, case sensitive, free from programming language that supports object oriented, procedural and generic programming. So here general purpose means using C++ a wide variety of problems can be solved. Case sensitive means C++ treats uppercase alphabets and lowercase alphabets as different. And free from language is a programming language in which the position of characters on the page in a programming text is insignificant. This means that a code can start on one line and ends several lines down and still can be a valid command. C++ is a middle level language. This means that since C++ consists of all the features of both high level and low level programming language, and so it is known as middle level language. Next, C++ is a superset of C. This means that C++ has all the features of C plus some new features like class, object, inheritance, polymorphism, etc. are added into it, and so C++ is a superset of C. Thus, all that can be done with C programs can also be done with C++ programs. Next, C++ is an extension of C with major difference of the class features of Simula 67. This means that the added features like class, object, inheritance, polymorphism, etc. in C++ are the features that were originally belonging to Simula 67 language. Next, the most important facilities that C++ adds to C are classes, inheritance, function overloading and operator overloading. Applications of C++. C++ is a versatile language. This means that C++ is suitable for developing any types of programs, including development of editors, compilers, database, communication system and complex real-life application system. Now, since C++ allows us to create hierarchy of related objects using which special object-oriented libraries can be created and which can be later used by programmers to build variety of softwares. Also, when new features are needed, it can be easily added to the existing C++ programs using inheritance and polymorphism, and thereby this makes C++ programs easily maintainable and expandable, and thus C++ can be used to build variety of different types of programs. Return type of main in C++ is integer. In C++, the return type of main is integer, and therefore every main function in C++ should end with return 0 statement, otherwise a warning or error might occur. Now 0 is returned to indicate to the operating system that program worked successfully and has terminated without any compile time or runtime error, whereas a non-zero value is returned to the operating system to indicate that some error occurred in program execution. Also, the default return type of all the functions in C++ is integer. Now, let us look at the different types of comments that are supported in C++. C++ supports two types of comments, single line comment and multi-line comment. The single line comment is indicated by double forward slash. This means that anything that follows double forward slash is a comment as shown in the slide. Multi-line comment. In multi-line comment, the beginning of the comment is indicated by a combination of forward slash followed by star, and the end of multi-line comment is indicated by star followed by forward slash. So anything between slash star and star slash is a comment as shown in the example. Also, for writing C++ program, the header file that needs to be included is iostream.h. Now we will see how to take the input from the user and display output to the user. So first we will see how to display output to the user. So in the statement cout double less than and within the quotation C++ is better than C. Now in this statement there are two features. First one is cout and second is double less than sign. So what is cout? Cout is a predefined object that represents the standard output stream in C++, and double less than operator is called insertion or put to operator. It takes the value of the variable and assigns it to cout object. Next, input statement, or how to take input from the user. So in the statement cin double greater than num1. So in this statement again there are two features. First one is cin and second one is double greater than sign. So what is cin? Cin is also a predefined object that represents standard input stream, and double less than operator is known as extraction or get from operator. It extracts or takes the value from the keyboard and assigns it to the variable on its right. Next, cascading of IO operators. So what is cascading of IO operators? So the multiple use of put to or get from operator in a single statement is called cascading of IO operator. Now as shown in example, cin get from operator, again num1, again get from operator, and num2. So in this statement we have used get from operator twice. Once between cin and num1 and second between num1 and num2. So here we have used get from operator more than once, and that is what is known as cascading of IO operator. In the same way we can also use put to operator multiple times as shown in the example. Say for example cout put to operator within inverted comma sum equal to, again put to operator, then sum variable, again put to operator, and then new line. So here we have used put to operator 3 times, and so it is known as cascading of IO operator. Inline functions. So what is an inline function? An inline function is a function that expands inline when it is invoked. This means when the inline function is called, the whole code of the inline function gets inserted or substituted at the point of inline function call. This substitution is performed by C++ compiler at compile time. Inline function may increase the efficiency of a program if it is small. This means that the compiler replaces the function call with the corresponding function code. So here compiler does not change the source code. However, this replacement of the function call with the corresponding function code is done in the object code that the compiler produces. However, one must notice that it's just a suggestion to the compiler. The compiler can ignore the inline request and may treat the function as a normal function. This means that programmer can make a function inline, but it depends upon the compiler to decide whether to treat it as an inline function or normal function. So how to create an inline function, or what is the syntax? Now, to make any function an inline function, start its definition with the keyword inline. As shown, let us look at the syntax. Inline, keyword, then after return type of the function, followed by function name and the argument list, then after the function body. Now let's look at an example of inline function. So this is a very simple example of inline function. Here in this example we have created an inline function named displayNum. This function prints a number that is passed as an argument to it. Now in the main function, displayNum function is called 3 times. In first call, 5 is passed as an argument. In the second call, 8 is passed, and in the third call 666 is passed. Now when this program is compiled, as shown in the image A, the compiler replaces the function call with the function body. So image A gets converted into image B after compilation. So in figure B, instead of calling displayNum function 3 times, you will see that the code of displayNum function is copied 3 times. So this is how inline function works. However, please note that compiler does not change source code. The replacement of function call with function body is done in object code. Now, why inline functions, or what is the need of inline functions? So as we know, every time a function is called, it takes lot of extra time in executing a series of instructions for tasks such as jumping to the function, saving the registers, pushing arguments into the stack, and returning to the calling function. This means that when the program executes the instruction that calls the function, that time CPU has to do the following tasks, such as store the memory address of the instruction that is written after the function call. Second, copy the arguments of the function to the stack. And finally, transfer the control to the function that is called. The CPU then executes the function code, stores the function's return value of the function in the predefined memory location, that is registers, and return control to the calling function. Now this can become overhead if the execution time of a function is less than the switching time from caller function to the called function. This means that if functions are large or they perform complex tasks, then the overhead of function call is usually insignificant, means we can ignore this as compared to the time the function takes to run. However, for small functions or small commonly used functions, the time needed to make the function call is often a lot more than the time needed to actually execute the function code. Now this overhead occurs for small functions because execution time of small function is less than the switching time. So one solution to this problem is to use macro. But the problem with macro is that they are not functions, and therefore error checking does not occur during compilation. And so C++ promotes a new feature called inline functions. The situations in which inline expansion or inline functions may not work. So here are some situations. First, for functions returning value if a loop, switch or goto exist. This means that a function is returning value to its caller, and function may contain statements such as looping, for loop, while loop, do while loop, etc. Or it may contain switch case or goto statement. In this situation, inline function may not work. Second, for functions not returning value if a return statement exists. Now, as shown in the example, we have some function whose return type is integer. So we need to write return statement within the sum function, but we are not explicitly returning any value. So this function will not expand inline. Third, if a function contains static variables. This means that if we have declared static variables inside the function, then we cannot make such a function inline. Next, if functions are recursive. Recursive functions are functions that calls itself, and so such functions cannot be expanded inline. And so these are the few situations where inline expansion may not work. Advantages of inline function. First, inline function improves the speed of the program execution by avoiding function calling overhead. This means that every time a function is called, it takes a lot of extra time in executing tasks such as jumping to the function. But since inline functions are expanded inline, the compiler replaces the function call with the corresponding function code, and this reduces the execution time. Second, it saves overhead of variables, push, pop on the stack when function calling happens. This means that since inline functions are expanded inline, and so there is no control transfer, and so there does not exist the need to save and restore the states of variables while passing the control to the calling functions and returning the control from the functions, and this saves the overhead of push and pop of variables. Third, it saves overhead of returning call from a function. When a function completes its execution, it returns to the calling program. Now, before returning, it needs to store the return value of the function in a predefined memory location or predefined registers, and then return the control to the calling function. This is purely overhead. Now with inline functions, there is no transfer of control, and so there does not exist this overhead. Now let us look at the disadvantages of inline function. First, the code is expanded during compilation, and so the executable file is larger. Now with inline functions, the compiler replaces the function call with the corresponding function code, and so if a same function is called 10 times, then the code of the function will be copied 10 times, and thereby the size of executable file becomes larger. Second, inline functions may increase compilation time overhead if someone changes the code inside the inline function. This means that if the code inside the inline function changes, then the compile time overhead increases. This is because the compiler would require to replace all the code once again to reflect this change. Otherwise, it will continue with old functionality, and so the overhead for the compiler increases. Third, inline functions may not be useful for many embedded systems. This is because in embedded system code size is more important than the speed. Fourth, inline functions may cause thrashing because inline might increases the size of binary executable file. In other words, if the executable file is too big, then the system might spend most of the time moving to the disk and fetching the next chunk of the code from the disk, and so this is purely overhead. Last, the compiler may not support them correctly. Now, all the compilers might not support inline functions as it is designed for. So, these are the different advantages and disadvantages of inline functions.